Hello, good evening, everybody. Welcome back to the third session of class on current electricity. So let me have a quick recap of what we have discussed. ನಿನ್ನೆ ಏನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ ಅದನ್ನ ಕ್ವಿಕ್ ರೀಕ್ಯಾಪ್ ಮಾಡಿ ಇವತ್ತಿನ ಕಾನ್ಸೆಪ್ಟ್ ನ ಡಿಸ್ಕಸ್ ಮಾಡಿ then we will take up questions on remaining concepts of the chapter. So we have already discussed regarding Ohm's law. So by mathematical representation, Ohm's law is given by V is equal to I into R, which gives the relation between current, voltage, and resistance. The resistance of a conductor is a constant. So voltage and current are directly proportional. That's what this law is indicating. So let's move on to next Kirchhoff laws. So Kirchhoff laws are applicable for networks where the series and parallel combination of resistors is not sufficient to resolve. If you need to apply, if you need to find out the value of unknown quantity in a network, then we can use this Kirchhoff laws. There are two laws. One is called as Kirchhoff's current law, which is called as KCL, Kirchhoff's current law. Okay, this is applicable for a junction or node. This is also called as junction law. So this is applicable for a junction. That means if there is a point where more than two or no branches of the circuits are meeting, the inward current, outward current. So let there be some currents which are inward, some currents are outward. What Kirchhoff current law states is this: algebraic sum of all the currents at a junction is equal to 0. That means ಎಷ್ಟು current inward ಇದೆ ಅಷ್ಟೇ current outward ಇರುತ್ತೆ. If sum of currents, inward currents is equal to 5 plus 5, 10, then outward current should also be equal to 10 or 10 ampere. Okay, so this is what Kirchhoff's current law is. Kirchhoff's voltage law is represented by KVL. So KVL is called as Kirchhoff's voltage law. What Kirchhoff voltage law states is that in a closed loop, imagine there is a closed loop. I'm just taking an example. So let there be a closed loop. In this closed loop, if the voltage across one of the cell is V1, voltage across the cell is V2, let the resistance be R1, R2, and R3. Now, so when there is current supplied, let the current be flowing in this direction. If current is assumed to be flowing in this direction, then current is flowing through this resistance R3 in this direction, R2 in this direction, and R1 in this direction. Okay, it's a closed loop. Now, what Kirchhoff current voltage law states? It states that the algebraic sum of all the voltage drop across various components. Eight components, the very components. All components across eight voltage drop aguttalla. Voltage drop na algebraic sum is equal to 0. Okay, so algebraic sum ತಗೊಳ್ತಿದೀವಿ. That means there are some voltages which are positive, some voltages will be negative. ಯಾವ voltage positive ಆಗುತ್ತೆ, ಯಾವ voltage negative ಆಗುತ್ತೆ. So there are rules. So ಇದು resistance ತಗೊಂಡ್ರೆ, if you are considering a resistance R, let the current be flowing like this. Okay, so if you are also negotiating, ಇವಾಗ ನಾವು let's take this is point A, B, C, D. So let me list the rules for sign convention. If you are negotiating also in the direction of current direction ನಾವು negotiate ಮಾಡ್ತಾ ಇದ್ದೀವಿ, closed loop na voltage na measure ಮಾಡ್ತಿದ್ದೀವಿ ಅಂತಂದ್ರೆ, then if you are negotiating in the direction of current, then voltage drop across this resistance is taken as negative. So V will be equal to minus IR. Okay, for the same case, here is I and here is R, but you are negotiating in the opposite direction. Now voltage drop na add ಮಾಡ್ತಾ ಬರ್ತಿದೀವಲ್ಲ, so that path, if it is opposite to direction of current, then voltage drop is taken as positive. V will become plus IR. Okay, so these are the rules applicable for resistors. Now let us consider what rule is applicable for batteries or cells. So yoga, for example, we have a battery, okay, with positive terminal and negative terminal. So as we keep on adding the voltage, ella voltage na ನಾವು add ಮಾಡ್ತಾ ಇದ್ದಾಗ, if you are negotiating from positive to negative terminal of the battery, so in such case the voltage drop will be equal to minus E. If E is the EMF of this battery or cell, so voltage drop will be equal to negative as we are moving from positive to negative terminal. All right. On the other hand, let's say there is a battery and we are negotiating in a direction opposite. That means we are moving from negative terminal to positive terminal. That means we are moving from lower potential to higher potential. So, in this case, the value of voltage drop V will be equal to plus E, where E is the EMF of the cell. Okay. So these are the same convention applicable for cells and batteries. So for cells and batteries, convention is this: voltage drop is equal to minus E if you are moving from positive terminal to negative terminal. Voltage drop will be equal to plus E if you are moving from negative terminal to positive terminal. Okay. So these are the rules that are applicable for applying Kirchhoff laws. Let us consider power. Okay. So whenever there is energy supplied, okay, the rate at which energy is supplied by a source or rate at which energy is consumed by a device, that is measured in terms of power. As you know, by definition, power is equal to energy consumed per unit time. Okay. The rate of consumption of energy is represented by power. Okay. So power is measured in terms of watt as the SI unit. So electrical power, if there is a device which is having some resistance or current flowing is I, let the potential difference across the resistor is V. Then what is the power consumed by this resistance? Okay, the power consumed by the resistance is given by power P is equal to product of current into voltage. P is equal to I into V. So by using Ohm's law, this can also be written in other forms such as P is equal to I square into R. P is equal to V square by R. Okay. So these are various expressions for power. Power can be expressed in terms of product of current into voltage, I square into R, or V square by R. So similarly, whenever current is flowing through a wire, that results in heating of the wire. Okay, wire will get heated up. The amount of heat produced is depending upon time. Okay, so that heat produced is given by a law called Joule's law. Heating effect, let's consider here. Let me consider heating effect. So this is about a quick recap of what basic laws in current electricity, Ohm's law, Kirchhoff laws, rules for applying Kirchhoff laws, power definition, expression for power. So heating effect, heat can be represented in terms of H is equal to I square R into T. So this is called as Joule's law of electrical heating. Let there be a resistor of resistance R. If current flowing through the resistance is I, if it is flowing for time T, then amount of heat produced is given by H equal to I square R into T. Okay. So this is about some basic terms, expressions. So please make a note of this. We'll move on to next one. Right. So moving on to next one. Cells. So cells are the sources of constant potential difference. Okay. If there is a device which can provide constant potential difference, that device can be called as a cell or a battery. A battery or cell are examples of constant potential difference. Okay. When there is no current, see, this circuit is open. If no current is drawn from a cell, then whatever is the potential difference, ಈ ಎರಡು ಟರ್ಮಿನಲ್ ಮಧ್ಯ ಎಷ್ಟು potential difference ಇರುತ್ತೆ ಅದನ್ನ ನಾವು EMF ಅಂತ ಕರಿತೀವಿ, right? EMF of a cell is the open circuit potential difference. If no current is drawn from the circuit, whatever is the potential difference in the open circuit, that potential difference is called as EMF E, represented by symbol E. Okay. Now, if you connect this to an external circuit having resistance some R, okay. So then what happens? Current starts flowing. When current starts flowing, whatever the voltage that we see across these 2 points is called as terminal voltage. Terminal voltage represented by symbol V. By definition, V is equal to current flowing multiplied by the external resistance applied. V is equal to I into R by Ohm's law. Okay. Now, as the current is flowing between the electrodes of the cell, there will be electrodes. Okay. Between the electrodes, charges are moving. I mean, between electrodes, there is electrolyte. Electrolyte in that offers some resistance flow of charges. The resistance offered by the cell for the movement of charges between the electrodes is called as internal resistance. Internal resistance is represented by symbol R. So what is the relation? What is the relation between this EMF of the cell, terminal voltage and internal resistance is given by this expression. The EMF of a cell is equal to, it is voltage drop across the external resistance plus I into R, which is the voltage drop across the internal resistance. Okay. So this gives the equation for relation between EMF of a cell, terminal voltage and internal resistance. So let's consider what is the expression for current by this. So expression for current can be done like this. E is equal to, you see V is equal to IR plus I into small letter r. So our E is equal to I times R plus R. This is the equation. Okay. Now what is the expression for current? Current supplied by the cell or battery of EMF E and internal resistance R is given by I is equal to E by R plus R. Okay. This is the basic expression for current supplied by the cell or a battery in terms of its EMF, external resistance and internal resistance. Okay. So this is about the basics of cells. In this class, actually, we will discuss regarding examples of analyzing circuits and we'll extend it to meter bits. Okay. So please make a note of this. We'll discuss regarding basics of meter bits. Right. So meter bits is an application of Kirchhoff laws. Okay. It's an application of balanced condition of Weierstrass network by using Kirchhoff laws. So let me write a diagram. A schematic representation of meter bits is like this. The schematic representation of meter bits diagram can be like this. This is called as left gap, LG, and this is called as right gap, RG. Okay. So this is galvanometer G, and this distance from one end of the wire. This is actually 1 meter wire. So this distance is called as balancing length. What is remaining is called as 1 minus L, remaining of 1 meter. Okay. Now, when the galvanometer is showing zero deflection, if current flowing through the galvanometer becomes zero, then we say the Weierstrass bridge network is balanced. If Weierstrass bridge network is balanced, then as we discussed yesterday, the ratio of these resistors P by Q is equal to R by S. Okay. So ಅಂದ್ರೆ ಇದನ್ನ ನಾವು P ಅಂತ ತಗೊಂಡ್ರೆ ಈ resistance ನ Q ಅಂತ ತಗೊಳ್ಳೋಣ. The resistance offered by this wire be called as R. ಈ resistor ನ ನಾವು S ಅಂತ ತಗೊಳ್ಳೋಣ. Okay. P, Q, R and S. Okay. So balancing condition ಏನಿರುತ್ತೆ? Balancing condition is this P by Q is equal to R by S. P ಅಂತ ಹೇಳಿದ್ರೆ resistance in the left gap. Q is the resistance in the right gap. R and S are the resistance of these wires. Okay, let's write this resistance in terms of lengths. ಈ resistance ನಾವು ಏನು ಬರಿಬಹುದು? Resistance R is equal to rho L by A ಇರೋದ್ರಿಂದ let's take resistivity of this wire is rho. It is rho by A into L1, which is the balancing length. Let's take L1 is the balancing length. Okay. Divided by resistance of this wire, which is called S. S na ಯಾವ ತರ ಬರಿಬಹುದು? Which is again rho by A, which is constant. See, resistivity same ಇದೆ ಈ wire throughout, and its area of cross section also is constant. So the remaining length ನಾವು 1 minus L1 ಅಂತ ಬರಿಬಹುದು, where L1 is balancing length. Okay. Right. ಇವಾಗ rho by A cancel ಮಾಡೋಣ. If you cancel rho by A cancel ಮಾಡಿದ್ರೆ, then we get P by Q. See, P ಮತ್ತೆ Q ಅಲ್ಲಿ one of the resistance can be unknown resistance. Okay. Other resistance has to be a known resistance. So ಇದರಲ್ಲಿ ಯಾವ್ದಾದ್ರು ಒಂದು unknown resistance ಇತ್ತು ಅಂದ್ರೆ, then we can find out the balancing length L1 and 1 minus L1. Balancing length ಕಂಡುಹಿಡ್ಕೊಂಡು one of the unknown resistance can be calculated. So this method can be used to find out the unknown resistance, and hence we can also find out resistivity of the unknown wire by using this method of meter bridge. Okay. So this is the application of meter bridge. Meter bridge is essentially based on balancing condition of Weierstrass bridge network. Okay. Right. Please make a note of this. We'll take up questions. Okay. So we'll take some examples of Network analysis. Please observe this question. In the circuit shown in figure, the total current supplied by the battery is. So look at the diagram. Here is battery of 6 volt. Resistance is 3 ohm here, 6 ohm here, 4 ohm here, and 3 ohm here. So resistance is given. Now we need to find out what is the value of current supplied. So we need to find out the value of current supply. So let me use. Okay. So how to find out the value of current? See, current by definition. I think this is visible clearly. Or let me use this. So current by definition, I is equal to V by R. Okay. So now V we have been given the value of V is equal to 6 volt. And what is the value of R equivalent? It's a network. We need to find out the value of equivalent resistance. Okay. So look at this diagram. E 6 ohm resistance in either 6 ohm and this 3 ohm resistors are connected to a common point here. They also have a common point all this length of the wire. Okay. So 6 ohm and 3 ohm resistance in either. This combination is in parallel combination. Okay. So 6 and 3 ohm resistors are in parallel combination. So using them, let's see, you can read the diagram like this. So let me write here 6 ohm and this is 3 ohm. Okay. 6 ohm and 3 ohm are in parallel combination. Right. So these two are in parallel combination. Being in parallel combination, what is the equivalent resistance of them? Equivalent resistance can be calculated by using R1 R2 by R1 plus R2. Okay. So it is 3 into 6 by 3 plus 6 will be equal to 18 by 9. So R equivalent comes out to be equal to 2 ohm. Okay. 6 ಮತ್ತೆ 3 ohm the equivalent resistance in ಬರುತ್ತೆ 2 ohm ಬರುತ್ತೆ. Right. This 2 ohm and this 4 ohm. Look at the diagram. Okay. Here we have got the equivalent of this 6 and 3 equal to 2 ohm. Okay. Now this 2 ohm and this 4 ohm are in series combination. Let me write the diagram of that part. So equivalent we have seen that is our 2 ohm and there is another 4 ohm resistance here. Okay. 2 ohm and 4 ohm are in series combination. What is the equivalent of them? So equivalent of them is equal to 6 ohm because if they are in series, we can add the resistances. Okay. So 6 ohm is the equivalent resistance. Okay. Now this 6 ohm and this 3 ohm, look at the diagram. So this 6 ohm here and this 3 ohm are in again parallel combination. So as we already know, 6 and 3 ohm in parallel combination will become 2 ohm. Right. So the diagram can be read down like this. Here is the 2 ohm resistance. Let me redraw the diagram like this. Here we have this 2 ohm, 4 ohm, which are in parallel combination, sorry, series combination, and their sum is in parallel with this 3 ohm resistance. Okay. So 2 ohm here, 2 plus 4 is 6, and 6 and 3 are in parallel combination. 6 and 3 in parallel combination. What is the equivalent resistance? Already we have seen here. So it is 2 ohm. So what is the value of R equivalent? R equivalent comes out to be R equivalent is equal to 2 ohm. Right? R equivalent is equal to 2 ohm. So what is the value of current? Let's find out the value of current. Current I is equal to V by R equivalent. Okay. So V is to the value of voltage here. The value of voltage is equal to 6 volts. So it is 6 volt by 2 ohm. The amount of current comes out to be equal to 3 ampere. So look at the options. 1 ampere, 2 ampere, 3 ampere given. So 3 ampere is the right answer. Okay.
Blue surface. Blue one. Yellow correct account. Blue light.
Yellow is better. Okay, so This is what the diagram is. Hope the answer is clear to all of you. So we need to find out the value of current. Current na calculate ಮಾಡಬೇಕು. So to find the value of current, what we need to find out is we also need to find out R equivalent because current is given by V by R equivalent. Okay. So V ಕೊಟ್ಟಿದ್ದಾರೆ V is equal to 6 volt. R equivalent comes out to be equal to 2 ohm. So knowing the value of R equivalent, we can find out the value of current. Current is equal to 3 ampere. Okay. Right. So please make a note of this answer. We'll move on to next question. Okay, consider this question. The question ready. 5 equal resistors each of value R are connected to form a network as shown in figure. Okay, so how many resistors are there? There are 5 resistors. Okay, so 5 resistors are there which are connected as shown in the network. Look at the network. Network is this. I'll redraw the network once again. What we need to find out is what is the equivalent resistance. The network na equivalent resistance S2. That's what we need to find out. So let me redraw the diagram. See, point A is here. This is our point A. This is our point B. So let me rewrite. This is our point B. And here is our point A and B. Okay. So other resistors are like this. There is one more resistance here. And there is a resistor between B and D. So let me write here. And look at this arm. Illi resistor R is there. R is there. So there are 2 resistors which are in series. So I can rewrite diagram like this. So diagram no itara now redraw ಮಾಡಬಹುದು. ಇದರಲ್ಲಿ ಈ resistors, all resistors are of equal value R. R is the resistance. ನಮಗೆ we want to know what is the resistance between equivalent resistance between these 2 points, point A ಮತ್ತೆ point B ಮಧ್ಯ AB. What is the resistance between point A and B is the question. Okay. First we'll solve from this side. Okay. ಇಲ್ಲಿ ನೋಡಿ ಈ ಎರಡು resistor ಏನಿದೆ, these 2 resistors are in series combination. These 2 resistors being in series combination, what is the equivalent resistance? R plus R will become 2R. 2R is the equivalent resistance of this part. Okay. ಈ 2R resistor ಮತ್ತೆ ಈ R resistors is in parallel combination. Let me redraw the diagram. Diagram ನೋಡಿ. This is our point A and here is our point B. So this is our R resistance and here is our equivalent resistance which is 2R. Okay, 2R is there, illi R is there. So these 2 are also equal to R and R. Now see, these 2 are in parallel combination. What is the equivalent resistance of them? Let's find out. So the equivalent resistance of these 2 is given by R into 2R by R plus 2R. Okay. So R into 2R is 2R square by R plus 2R is 3R. The R ಮತ್ತೆ square na cancel ಮಾಡೋಣ. So we get 2R by 3. The equivalent resistance of this part will become 2R by 3. Right? ನಮಗೆ we want to know what is the total equivalent resistance, right? ಈ total part the resistance ಎಷ್ಟಾಗಿದೆ ಇವಾಗ? This is equal to 2R by 3. 2R by 3 this part. Okay. This 2R by 3 and this R is in series combination. Okay. ನೀವು diagram na redraw ಮಾಡಿದ್ರೆ let me write here or let me write here. So let me write the extended diagram. Now we have this R between points B and A. This is our point B and point A. We have another resistance R here. Okay. ಈ ಎರಡು resistors the equivalent ಎಷ್ಟಾಗಿದೆ? Equivalent is 2R by 3. So let me write here. So ಇವಾಗ ನೋಡಿ ಈ 2R by 3 and this R resistance, these 2 are in series because ನಮ್ಮ where we are finding the equivalent resistance, we are finding equivalent resistance between these 2 points. ಈ ಎರಡು ಪಾಯಿಂಟ್ ಮಧ್ಯ ನಾವು equivalent resistance ನ ಕಂಡುಹಿಡಿತಿರೋದ್ರಿಂದ ಈ ಎರಡು resistance ಏನಾಗುತ್ತೆ series ಅಲ್ಲಿ ಆಗುತ್ತೆ. So these 2 resistors are in series. So all we need to do is to add them. We have to add ಮಾಡಬೇಕು. So if you add them, you will see that 2R by 3 plus R ಎಷ್ಟಾಗುತ್ತೆ? 3R plus 2R is 5R by 3. So 5R by 3 is the equivalent resistance. ಈ R ನ ಒಂದು ಬಿಟ್ಟು ಉಳಿದಿರೋ ಎಲ್ಲಾ resistance ನ ನೀವು add ಮಾಡಿದ್ರೆ ಎಷ್ಟು resistance ಬರುತ್ತೆ is 5R by 3. Okay. Now let's come to the last diagram. Let me write the last diagram here. ಇಲ್ಲಿ ನೋಡಿ. The last diagram is this. This is our point B and here is our point A. Okay. A ಮತ್ತೆ B ಮಧ್ಯ R resistance ಇದೆ. The equivalent resistance that we have found, remaining all resistance, the equivalent resistance ಎಷ್ಟು ಬರ್ತಿದೆ, it is equal to 5R by 3. So let me add here resistance which is 5R by 3. This is 5R by 3. Now look at this diagram. 5R by 3 ಮತ್ತೆ ಈ R ಏನಿದೆ, these two are in parallel combination. So we need to find out what is the equivalent resistance. So our final answer RAB is this. It is R1 R2 by R1 plus R2 of these two. That is R into 5R by 3 by R plus 5R by 3. Okay. So ಎಷ್ಟಾಗುತ್ತೆ ಇದು? This is 5. So it is R plus 5R by 3. So let's simplify. So this is 5R square by 3 and here it is 3R plus 5R, 8R by 3. So by 3 cancel ಮಾಡೋಣ. R ಮತ್ತೆ R square ನ simplify ಮಾಡೋಣ. So your answer is 5R by 8. So 5R by 8 is option 3. Option 3 is the right answer. So look at the solution once again. ನೀವು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಯು ಡೋಂಟ್ ನೀಡ್ ಟು ರೈಟ್ ದಿಸ್ ಆಲ್ ದಿ ಡಯಾಗ್ರಾಮ್ ನೀವು ಬರೆಯೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ನಾನು ಯಾಕೆ ಬರ್ದಿದ್ದೀನಿ ಅಂದ್ರೆ ಟು ಎಕ್ಸ್ಪ್ಲೈನ್ ನಿಮ್ಗೆ ಇಲ್ಲಿಂದ ಈ ಡಯಾಗ್ರಾಮ್ ಯಾವ ತರ ಬಂತು. ಸೊ ಟು ಎಕ್ಸ್ಪ್ಲೈನ್ ಐ ಹ್ಯಾವ್ ರಿಟನ್ ದ ಡಯಾಗ್ರಾಮ್ ಫಾರ್ ಯು ಇನ್ ಎಕ್ಸಾಮ್ ಯು ಕ್ಯಾನ್ ಡೈರೆಕ್ಟ್ಲಿ ಸಾಲ್ವ್ ದಿಸ್ ಕ್ವಶನ್ ಬೈ ವಿಜುವಲ್ ಇನ್ಸ್ಪೆಕ್ಷನ್. ಸೊ ಲೆಟ್ ಮಿ ಟೆಲ್ ಯು ಹೌ ಟು ಸಾಲ್ವ್ ದಿಸ್ ಕ್ವಶನ್ ವಿತೌಟ್ ರೈಟಿಂಗ್ ಎನಿಥಿಂಗ್. ಓಕೆ, ನಿಮಗೆ ಪಾಯಿಂಟ್ ಎ ಅಂಡ್ ಬಿ ಕೊಟ್ಟಿದಾರಲ್ವಾ, ಇವೆರಡರ ಮಧ್ಯೆ ನಾವು ರೆಸಿಸ್ಟೆನ್ಸ್ ನ ಕಂಡುಹಿಡಿಯಬೇಕು. ಯು ಡೋಂಟ್ ನೀಡ್ ಟು ರೈಟ್ ಎನಿಥಿಂಗ್, ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ದ ಡಯಾಗ್ರಾಮ್. So ಈ ಎರಡನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಫಸ್ಟ್ these two are in series combination, their equivalent is 2R. Okay, 2R ಮತ್ತೆ ER parallel combination ಇದೆ. 2R and R in parallel combination, you will arrive at 2R by 3. ಈ 2R by 3 ಮತ್ತೆ ER ಏನಿದೆಯಲ್ಲ, they are in series. 2R by 3 plus R will become 5R by 3. Okay, 5R by 3 ಮತ್ತೆ ER ಏನಿದೆಯಲ್ಲ, they are in parallel combination. 5R by 3 into R by 5R by 3 plus R, you will get 5R by 8. So 5R by 8 is our answer. So observe this. ಈ diagram ನ ಬರೀಲೇಬೇಕು ಅಂತಿಲ್ಲ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ. So you can solve them without writing. Just finding out what is the equivalent resistance of these different parts. Okay, so please make a note of the answer. We will take some other questions of circuit analysis. Let's take the next question. The given figure shows network of resistances. Effective resistance between point A and B of network is, okay, ಈ resistance network ಏನಿದೆಯಲ್ಲ, ಇದರ effective resistance between A and B. Okay, so we need to find out what is the effective resistance between points A and B. ನೀವು diagram ನ observe ಮಾಡಿದ್ರೆ, so here you will see that this is point A and this is point B. We want to find out what is the equivalent resistance of this network between A and B. So ಈ resistance may be appearing complicated. ನೋಡಿದ್ರೆ complicated ತರ ಕಾಣ್ತಾ ಇದೆ, but it's not complicated. It's very, very simple. Let us see how to analyze such a circuit. So let me redraw the diagram. Let me redraw it here. Okay, this is the diagram. So here you see, ಈ value ಏನಿದೆ, this value of resistance is 3 ohm. ಇದು 3 ohm ಇದೆ, ಇದು ಕೂಡ 3 ohm ಇದೆ. And observe that we want to find out what is the equivalent resistance between these two points. This is our point A. This is our point B. A ಮತ್ತೆ B ಮಧ್ಯೆ ಇರೋ equivalent resistance ಬೇಕು ನಮಗೆ. So diagram is like this. Now the diagram is clear, visible. Okay. If it is not, let me write this resistances here. Here is 3 ohm and here is 3 ohm. Okay. Got it. Now 3 ohm and 3 ohm resistance in there. These two resistors are in series combination. Okay. You can see E resistor and 2 resistors in there series combination in there. Okay, so this is the diagram. You see, either 3 ohm is there, E resistance 3 ohm is there. So for this two 3 ohm resistance series their equivalent resistance is equal to their equivalent resistance comes out to be equal to 6 ohm. Resistance na equivalent resistance in barutte 6 ohm ಇದೆ. ಆಮೇಲೆ look at this resistance given in the diagram. ಈ diagram ಅಲ್ಲಿ resistance value ಏನಿದೆ ಇದು 6 ohm ಇದೆ. Now this 6 ohm and 6 ohm, these two 6 ohm resistors are in parallel combination. So parallel combination ಇರೋದ್ರಿಂದ ಎರಡು 6 ohm resistance parallel combination ಇತ್ತು ಅಂತಂದ್ರೆ R by 2 is equal to 3 ohm ಆಗುತ್ತೆ. RP parallel combination ಅಲ್ಲಿ RP is equal to R by 2 formula. R is equal to 6 by 2 will become 3 ohm. The effective resistance of this 6 ohm and this 6 ohm. Okay, so this 6 ohm and the given 6 ohm. ಈ ಎರಡು resistors the effective value ಏನು ಬರುತ್ತೆ? It is 3 ohm. Now look at this diagram. ಈ 3 ohm ಮತ್ತೆ ಇಲ್ಲಿ 3 ohm ಇದೆ. Okay, 3 ohm and this 3 ohm are in series combination. We need to add them. So again, our effective resistance will come out to be equal to RS. Let me call RS will be equal to 3 plus 3 will become 6 ohm. ಅಂದ್ರೆ ಈ resistance equivalent ಎಷ್ಟಿದೆ? It is equivalent to 3. 3 plus this 3 will become again 6 ohm resistance. Okay. Now let me consider that 6 ohm resistance and you see this another 6 ohm resistance here. 6 and 6 are in parallel combination. So parallel combination ಅಲ್ಲಿ 6 by 2 3 ಆಗುತ್ತೆ. And again this is another 3 ohm resistance. 3 plus 3 will become 6. Okay. So again that 6 and this 6 ohm resistors are in parallel combination. So 6 and 6 in parallel combination will reduce to 3 ohm. 3 plus this 3 ohm resistance will become again 6 ohm. Okay. So final resistance here is 3 ohm. Okay. So what we have is equivalent resistance in bandittu is 6 ohm. Now finally we need to have this 6 and 3 ohm in parallel combination. So 6 and 3 ohm in parallel combination, let me call it as R effective. R effective ನೀವು calculate ಮಾಡಿದ್ರೆ R effective comes out to be equal to R effective is equal to R1 R2 by R1 plus R2 formula. So R effective will be equal to E R1 is the final value. This is 3 and what we have obtained by reducing all this is 6. So it is 3 into 6 by 3 plus 6. 3 into 6 18. 3 plus 6 9. So equivalent resistance will be equal to 2 ohm. So for this question, answer is 2 ohm. Option 4. Option 4 right answer ಆಗುತ್ತೆ. So please observe the diagram. Again, such kind of questions can be solved without writing anything. Visual inspection ಮಾಡಿ solve ಮಾಡಬಹುದು. Let me explain how to solve this question by visual inspection. ನೋಡಿ ಪಾಯಿಂಟ್ A ಮತ್ತೆ B ಮಧ್ಯೆ ನಮಗೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಬೇಕು. You want to find resistance between point A and B. So extreme end ಇಂದ ಶುರು ಮಾಡೋಣ. Where we can decide which resistors are in series or parallel. ನೀವು extreme end ಇಂದ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಈ ಎರಡು resistors ಏನಿದೆ series combination ಇದೆ ಅದರ equivalent will become 6. ಈ 6 ಮತ್ತೆ ಈ 3 ohm ಏನಿದೆಯಲ್ಲ they are in series. ಅವಾಗ I'm sorry. Let me erase this. ಇಲ್ಲಿ ನೋಡಿ ಈ 6 ohm ಮತ್ತೆ ಈ 6 ohm ಏನಿದೆಯಲ್ಲ this 6 ohm, these two, this 6 ohm and this 6 ohm, these two are in parallel combination. 6 and 6 ohm in parallel combination will reduce to 3 ohm ಆಗುತ್ತೆ. 3 ohm plus 3 ohm will become 6. 6 and 6 again becomes 3. So ಈ ಮೆಥಡ್ ಅಲ್ಲಿ ನೀವು ಪ್ರೊಸೀಡ್ ಮಾಡಿದ್ರೆ ಈ ತರ ಕ್ವೆಶ್ಚನ್ ನ we can solve by visual inspection without writing anything. So ನೀವು ಡಯಾಗ್ರಾಮ್ ನ ಬರೆಯೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಡಯಾಗ್ರಾಮ್ ಬರಿದೇನೆ visual inspection ಮಾಡಿ you can calculate what is the equivalent resistance. Okay. So 3 plus 3 6. 6 and 6 parallel combination ಇರೋದ್ರಿಂದ 3 ಆಗುತ್ತೆ. 3 plus 3 becomes 6. 6 and again this 6. will become 3. 3 and 3 will become 6 series combination, and 6 and this 6 will become again 3. 3 and this 3 will become 6. The finally ನಮಗೆ ಈ 6 ohm ಮತ್ತೆ 3 ohm resistance ಮಾತ್ರ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. So 6 into 3 by 6 plus 3, that gives 2 ohm. 2 ohm is the answer. So please make a note of this answer. Answer na note ಮಾಡ್ಕೊಳ್ಳಿ. Right. Let's move on to next question. This is a very interesting question. Look at the diagram. So we are asked to find out what is the potential difference across one of the resistor. Okay. So diagram is like this. In the circuit shown in figure, potential difference across 3 ohm resistance is. So in diagram nodi. So in this case, in this diagram, we want to know what is the value of potential difference across 3 ohm resistance. ಈ resistance ನಾವು V ಅಂತ ಕರೆಯೋಣ. We want to know what is the value of this V across 3 ohm resistance. That's the question. So ಇಲ್ಲಿ current ಕೊಟ್ಟಿದ್ದಾರೆ. Current is equal to 2 ampere. 2 ampere ಇಲ್ಲಿ ಎರಡು branch ಇದೆ. For these two branches, current is dividing. Let's find out how the current is dividing. For that, let me write an equivalent diagram. ಈ diagram ನ ನಾವು redraw ಮಾಡಿದ್ರೆ, see ಇಲ್ಲಿ 6 and 3 are in parallel combination. So what is the value of equivalent resistance for the parallel combination? Let me write it as RP. RP is equal to by formula it is R1 R2 by R1 plus R2. Okay, so this is 3 into 6 by 3 plus 6, which we find as 2 ohm. Okay, so ಎರಡು parallel combination resistance ಏನಿದೆ 2 ohm ಆಗುತ್ತೆ. So their equivalent is equal to 2 ohm. 2 ohm ಮತ್ತೆ ಈ 2 ohm ಏನಿದೆಯಲ್ಲ, these two 2 ohm resistors are in series combination. So for series combination, let me write RS is equal to 2 ohm plus 2 ohm. So RS will be equal to 4 ohm. So ಈ diagram ಅನ್ನು ನೀವು redraw ಮಾಡಿದ್ರೆ ನಮಗೆ ಇಲ್ಲಿ 2 ampere current ಬರ್ತಾ ಇದೆ. This 2 ampere current sees ಈ total resistance upper branch ಅಲ್ಲಿ ಎಷ್ಟಿದೆ 2 plus 2 4 ಆಗುತ್ತೆ. So 4 ohm here, and lower branch ಅಲ್ಲಿ resistance ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ, it is again given 4 ohm. So ಇಲ್ಲಿ ಕೂಡ 4 ohm ಇದೆ. So look at the diagram. So resistance here is 4 ohm in the upper branch, resistance here is 4 ohm in the lower branch. ಈ current 2 ampere ಏನಿದೆಯಲ್ಲ, this current will divide equally. The current will divide equally into both the branches. So ಈ 2 ampere current, the amount of current here is 2 ampere. So 2 ampere current will, this 2 ampere current will divide into two equal parts. Current here will become 1 ampere. And current here becomes again 1 ampere. ನೋಡಿ 1 ampere ಆಗಿ current divide ಆಗುತ್ತೆ. So ಈ 1 ampere divide ಆಗಿರೋ current ಈ 3 ohm ಅಲ್ಲಿ ಎಷ್ಟು, what is the voltage it produces, right? ಎಷ್ಟು current flow ಆದ್ರೆ B voltage ಬರುತ್ತೆ, let's find out. Okay, so anyway, what thing we have understood is this: current ಇಲ್ಲಿ ಎಷ್ಟು flow ಆಗುತ್ತೆ 1 ampere, ಇಲ್ಲಿ ಎಷ್ಟು flow ಆಗುತ್ತೆ, current will be equal to 1 ampere. ಈ 1 ampere current flow ಆಗೋದ್ರಿಂದ what is the voltage across this 4 ohm? Let's calculate. ಈ voltage ನೀವು ಬರೆದ್ರೆ V is equal to I into R. See, I is equal to 1 ampere ಇದೆ, R is equal to 4 ohm ಇದೆ. So our resistance V comes out to be equal to 4 volt. So sorry, voltage comes out to be 4 volt. ಇಲ್ಲಿ ಎಷ್ಟು voltage drop ಆಗುತ್ತೆ? The amount of voltage drop here is 4 volt. Okay, see ಇಲ್ಲಿ voltage drop 4 volt ಆದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ ಈ diagram ಅಲ್ಲಿ ಈ 2 volt ಈ combination ಅಲ್ಲಿ 2 volt drop ಆಗುತ್ತೆ, ಈ combination ಅಲ್ಲಿ 2 volt drop ಆಗುತ್ತೆ, because here we have seen that voltage drop is equal to 4 volt. Okay, so 4 volt voltage drop ಆಗ್ತಾ ಇದ್ರೆ then that 4 volt will get divided equally across these two. ಎರಡು part ಏನಿದೆ parallel combination and this 2 ohm resistance, ಎರಡು part ಅಲ್ಲೂ 2 ohm equal ಇರೋದ್ರಿಂದ voltage ಕೂಡ equal ಆಗಿ divide ಆಗುತ್ತೆ, right? So amount of potential difference here is 4 volt, because what current is flowing here is 1 ampere. 1 ampere into 4, V is equal to I into R, 4 volt. Okay, so now directly ಈ 4 volt ಇಲ್ಲಿ 2 ಮತ್ತೆ 2 ohm resistors ಅಲ್ಲಿ equal ಆಗಿ divide ಆಗುತ್ತೆ. So total potential difference across both of them is equal to 2 volt. So our answer for this question will be 2 volt. So 2 volt is the answer. So observe here. So here is 4 volt which is dropped across these 2 points. because current flowing here is 1 ampere. Current flowing here also will be equal to 1 ampere because the effective resistance is 4 ohm here, 4 ohm here. Current divides equally. So because of the equal resistance here, 2 ohm here because of the combination and 2 ohm here, the 4 volt will get divided equally. 4 volt equal ಆಗಿ ಎರಡು ಕಡೆ divide ಆಗುತ್ತೆ. So it is 2 volt plus 2 volt. So right answer for what is the voltage across 3 ohm is 2 volt. Observe ಮಾಡಿ ಇದು parallel combination ಇದೆ. ಎರಡು across voltage same ಇರುತ್ತೆ. 2 volt is the potential difference. Please have a look at the solution. Okay, let's move on to next question. Okay, let's consider this question. This question nodi, a uniform wire of resistance 36 ohm is bent in the form of a circle. The effective resistance across points A and B is, what is the effective resistance between these 2 points? A ಮತ್ತೆ B ಮಧ್ಯ effective resistance ಏನಿರುತ್ತೆ? That's the question. So let's find out what is the answer. See, total wire na resistance ಏನಿದೆ? There is a uniform wire. There is a uniform wire of resistance 36 ohm. Andre, let's take there is a wire whose resistance is equal to 36 ohm. ಈ 36 ohm ಇರೋ wire ನ ನಾವು we are bending in the form of a circle. Circle ಆಗಿ bend ಮಾಡಿದೀವಿ. Let's consider 2 points. One point is here, other point is somewhere here. Okay, so this is point B and this is point A. The center ಇಂದ ನೀವು observe ಮಾಡಿದ್ರೆ this A and B are subtending an angle 60 degree. So they are subtending an angle 60 degree. So total wire ಏನಿದೆ 36 ohm 36 ohm resistance ನ ನಾವು 2 part ಆಗಿ divide ಮಾಡ್ತಿದ್ದೀವಿ. Let's call between A and B. ಈ 36 degree angle ಅಲ್ಲಿ ಎಷ್ಟು resistance ಇದೆ ಅದನ್ನ R1 ಅಂತ ಕರೆಯೋಣ. Whatever the resistance that is there between here, okay, ಈ resistance ನ ನಾವು R2 ಅಂತ ಕರೆಯೋಣ. So they will have two resistors, R1 and R2. R1 ಮತ್ತೆ R2 resistor parallel combination ಇರುತ್ತೆ. Let's find out what is the equivalent resistance between point A and B. ಇವಾಗ let's find out the value of R1. ನೀವು R1 ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ, how to calculate R1? See, total resistance ಏನಿದೆ 36 ಇದೆ. Let's find out what is the value of resistance per unit angle. Okay, total resistance ನಾವು 360 degree ಆಗಿ ಬೆಂಡ್ ಮಾಡಿದೀವಲ್ವಾ, ಸರ್ಕಲ್ ಅಂತ ಹೇಳಿದ್ರೆ in a circle how much is the angle? Circle, the total angle subtended in a circle will be equal to 360 degrees. So let's find out the value of R1. R1 ಎಷ್ಟಾಗುತ್ತೆ? Total resistance 36 ohm divided by 360 into 60 degree. Okay, 36 divided by 360 will give what is the resistance per unit angle. Resistance per unit angle multiplied by angle subtended here, which is 60 degree. So ಇದು ನಮಗೆ R1 value ನ ಕೊಡುತ್ತೆ. ನೀವು simplify ಮಾಡಿದ್ರೆ this is 10 times. Okay, so ಇದನ್ನ simplify ಮಾಡಿದ್ರೆ you will get R1 is equal to 6 ohm. Okay, ನಿಮಗೆ R1 6 ohm ಅಂತ ಗೊತ್ತಾದ್ರೆ, if R1 is equal to 6 ohm, you tell me what is R2? 36 ಅಲ್ಲಿ 6 ohm R1 ಆದ್ರೆ the remaining value will be R2. R2 will be equal to 36 minus 6. So R2 will be equal to 30 ohm. Right? R2 value ಏನಾಗುತ್ತೆ? 30 ohm ಆಗುತ್ತೆ. So once you know the value of R2 is 30 ohm, let us calculate. Let's calculate what is the equivalent resistance. Like ನಮಗೆ ಈಗ two values ಗೊತ್ತಾಗಿದೆ. ಒಂದು R1 is equal to 6 ohm, and what is R2? R2 is equal to 30 ohm remaining. 36 minus 6, 30 ohm, right? ಇವಾಗ ಈ ಎರಡು resistors parallel combination ಇದೆ. We want to find out what is the equivalent resistance. Okay, to find out the equivalent resistance, we have this formula. RP is equal to ಏನು? R1 R2 by R1 plus R2. Okay, this is our RP. So let's find out what is RP. Substitute ಮಾಡಿ ಇಲ್ಲಿ R1 6 ಇದೆ, R2 30. By R1 plus R2, 6 plus 30 is 36. So it is 6 into 30 by 36. Cancel ಮಾಡಿ 6 times 6 5s are 30. So RP comes out to be 5 ohm. So answer for the question is 5 ohm. 5 ohm equivalent resistance ಆಗುತ್ತೆ. So in this case it is option 1. Option 1 is the right answer. So please make a note of the answer. Okay, let's move on to next question. Again, this is another question on network analysis, which can be solved by without writing. ನೀವೇನು ಬರೆಯೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ನೋಡಿ diagram na solve ಮಾಡಬಹುದು. Let us see what is given in the question. In the figure shown, the circuit shown in figure, current through 3 ohm resistance is. What is the value of current through this 3 ohm resistance? ಈ 3 ohm resistance ಏನಿದೆಯಲ್ಲ, ಆ resistance ಅಲ್ಲಿ ಎಷ್ಟು current flow ಆಗುತ್ತೆ? That's what you need to calculate. Okay, so ಈ 3 ohm ಅಲ್ಲಿ ಎಷ್ಟು current flow ಆಗುತ್ತೆ? See, this is a 9 volt battery. Current will be sent like this. How much is the current flowing through this 3 ohm resistance is the question. So for this question, again, what I would suggest is to solve this question without writing anything. Visual inspection in the solve ಮಾಡೋದು. That is, see, look at this experimental ನೋಡೋಣ, where there are resistors in either series or parallel combination, we can solve them. ಇದು ನೋಡಿ 2 ohm resistance ಇದೆ, ಇಲ್ಲಿ 4 ohm resistance ಇದೆ. 2 ohm, 4 ohm, and this 2 ohm. These three resistors are in series combination. 2 plus 4 plus 2 will become 8. Okay. The 8 ohm resistance in there. This 8 ohm resistance is in parallel combination with this 8 ohm resistance. E 8 ohm resistance matte E 8 ohm resistance, they are in parallel combination. 8 and 8 ohm resistance in parallel combination ಏನಾಗುತ್ತೆ? RP is equal to 8 by 2. 8 by 2 will become 4 ohm. Okay. So ಈ 8 ohm ಮತ್ತೆ ಈ 8 ohm parallel combination the equivalent ಏನ್ ಬರುತ್ತೆ? 4 ohm ಆಗುತ್ತೆ. Okay. Now ಆ 4 ohm ನ ನೀವು ಇಲ್ಲಿ substitute ಮಾಡಿ. Substitute that 4 ohm here. Okay. ಇದನ್ನ complete remove ಮಾಡಿ. We have got only 4 ohm here. So 4 ohm plus 2 plus 2 will become again 8 ohm. Okay. 4 plus 2 6, 6 plus 2 8 ohm. So we'll have another 8 ohm resistance which is parallel to this 8 ohm. 8 and 8 ohm in parallel combination will give again 4 ohm. So ಇಲ್ಲಿ ನೋಡಿ. So what we get here is a equivalent of 4 ohm. Alright, 8 and another 8 ohm resistance in parallel combination will give 4 ohm. Yoga complete diagram na replace madi. We have only this diagram. Let me redraw the diagram. 9 ohm, 9 volt battery here. We have a 3 ohm resistance. We have a 4 ohm equivalent value and another 2 ohm. Okay, now you see 4 plus 3, 7, 7 plus 2, 9. Our equivalent resistance of this all resistors together is equal to 9 ohm. Voltage ನೋಡಿ ಎಷ್ಟಿದೆ? Voltage is equal to 9 volt. Resistance is 9 ohm. So we can find out what is the value of current. So our current equation, current I is equal to V by R is the formula. So V is equal to 9 volt idralli and R is equal to 9 ohm. So the value of current I comes out to be equal to 1 ampere. So 1 ampere current is supplied by the battery and that 1 ampere has to flow this 3 ohm. ಈ ಬ್ಯಾಟರಿ ಅಲ್ಲಿ ಎಷ್ಟು ಕರೆಂಟ್ ಫ್ಲೋ ಸಪ್ಲೈ ಮಾಡುತ್ತಲ್ಲ ಅಷ್ಟು ಕರೆಂಟ್ ಈ 3 ohm ಅಲ್ಲಿ ಫ್ಲೋ ಆಗುತ್ತೆ. So total current flowing through the battery will be equal to 1 ampere. So option 3 is the right answer. Please make a note of the answer. Answer ನೋಡಿ. So right answer for this question is 1 ampere. Let's move on to next one. Okay, let's take up questions of meter bridge first. Look at this question. The resistance to be connected in parallel with 12 ohm resistance in circuit, so the potential difference between B and D is 0. Diagram nodi. So in the diagram, ನಮಗೆ what is the resistance to be connected across this 12 ohm resistance? ಈ 12 ohm resistance ಏನಿದೆಯಲ್ಲ ಅದಕ್ಕೆ ಜೊತೆಗೆ ಪ್ಯಾರಲ್ ಆಗಿ ಎಷ್ಟು resistance ನ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ B ಮತ್ತೆ D ಮಧ್ಯ potential difference 0 ಆಗುತ್ತೆ. That's the question. Okay. So we want to find out what is the value of resistance X. So ಇಲ್ಲಿ let us take, we want to achieve this condition of VB is equal to VD. VB ಮತ್ತೆ VD equal ಆಗಬೇಕು ಅಂತಂದ್ರೆ then potential difference between them is 0. That means it's a balanced switch to bridge network ಆಗುತ್ತೆ, right? So if the potential difference between these two has to be 0, ನಮಗೆ balancing condition ಗೊತ್ತಿದೆ. You call it as some B, Q, R, S. So balancing condition ಆಗಬೇಕು ಅಂತಂದ್ರೆ P by Q is equal to R by S. Okay. So P value ಕೊಟ್ಟಿದ್ದಾರೆ. P value is equal to 6 ohm. Q value, okay, we need to find out the value of Q. Okay, R value is given, R is 12 and S value is given, S is 6. So ಈ values ಕೊಟ್ಟಿದ್ದಾರೆ, ನಮಗೆ Q value ಗೊತ್ತಿಲ್ಲ. So across this 12 ohm we have to connect some resistance here, let's call it as some X. Okay, X resistance ನಾವು ಇಲ್ಲಿ connect ಮಾಡಬೇಕು. Connect ಮಾಡಿದ್ರೆ then the Wheatstone bridge network will become balanced Wheatstone bridge network. Okay, so ಯಾವ value ನ ಇಲ್ಲಿ connect ಮಾಡಿದ್ರೆ ಇದು balanced Wheatstone bridge ಆಗುತ್ತೆ. That's what we need to find out. So let's find out what is the value of right. So ಇದರ ಟೋಟಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನಿದೆ ಅದನ್ನ ನಾನು Q ಅಂತಾನೆ ರಿಟರ್ನ್ ಮಾಡ್ತೀನಿ. Okay, so we need to find out what is the value of this Q. ಇವಾಗ ನೋಡಿ P by Q is equal to R by S is the required condition. P ಎಷ್ಟಿದೆ 6 ಇದೆ. 6 by Q is equal to R ಎಷ್ಟಿದೆ 12 ಇದೆ. 12 by 6, you see 12 by 6 is equal to 2. ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ನಿಮಗೆ 2 ಬರುತ್ತೆ. So we have 6 by Q is equal to 2 ಆದ್ರೆ Q is equal to ಏನಾಗುತ್ತೆ, Q will be equal to 3. ಅಂದ್ರೆ the equivalent resistance that is supposed to be here is 3. Okay, so ಇದು 2 times ಇದೆ, so ಇದರ 2 times ಆಗಬೇಕು ಅಂತಂದ್ರೆ ಇದು 3 ಆಗಬೇಕಾಗುತ್ತೆ, right? So we have the value of Q is equal to 3. So Q is equal to 3 ಇದೆ, ಯಾವ ವ್ಯಾಲ್ಯೂ ನ ರೆಸಿಸ್ಟೆನ್ಸ್ ನಾವು ಪ್ಯಾರಲಲ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಇದು 3 ಆಗುತ್ತೆ. That's what we need to find out now. What is the value of X for which ಈ ರಿಸಲ್ಟೆಂಟ್ ನಮಗೆ 3 ಆಗೋದಕ್ಕೆ ಎಷ್ಟು ವ್ಯಾಲ್ಯೂ ನ ತಗೋಬೇಕಾಗುತ್ತೆ? ಲೆಟ್ ಮೀ ಕನ್ಸಿಡರ್ ಹಿಯರ್. ಇಲ್ಲಿ ನೋಡಿ, so value of Q is equal to 3 ohm. This 3 ohm is equal to, ಇದು ಪ್ಯಾರಲಲ್ ಕಾಂಬಿನೇಷನ್ ಇರೋದ್ರಿಂದ ಇದು 12 into X by 12 plus X ಆಗುತ್ತೆ. Okay, so if you simplify ಇದನ್ನ 3 ಮತ್ತೆ 12 ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡೋಣ 4 times. So ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ 12 plus X is equal to 4x. 12 plus x is equal to 4x. ಈ x ನ ಈ ಕಡೆ ತಗೊಳ್ಳಿ. 12 is equal to 4x minus x will become 3x. Okay, 4x minus x is equal to 3x. Now if you simplify, x is equal to what? X is equal to 12 by 3, that is 4. So 4 is the answer. Okay, so what is the resistance that need to be connected across 12 ohm so that potential between B and D becomes 0 is 4 ohm. So our answer for value of X is equal to 4 ohm. So please make a note of the answer. So the solution is clear. The condition is we want to achieve this P by Q is equal to R by S. So andre here I have substituted P by Q is equal to andre 6 by Q is equal to 12 by 6. 6 by Q is equal to 12 by 6, which is 2. So ನಮಗೆ 6 by Q is equal to 2 ಬರುತ್ತೆ. So Q is equal to 3. Q is equal to 3 ಗೊತ್ತಾದ್ರೆ we can find out what should be the value of X so that Q value becomes 3. Okay, so let's take another question. So look at this question. Two resistances are connected in two gaps of a meter bridge. The balance point is 20 centimeters from 0, and a resistance of 15 ohm is connected in series with smaller of the two. Null point shifts to 40 centimeters. The value of smaller resistance in ohm is. So smaller resistance na value ಏನಿದೆ? That's what we need to calculate. Okay. See, let me redraw the diagram. We have left gap, we have right gap, and this is the meter bridge. This is the 1 meter wire. Okay, so here is our galvanometer, and somewhere here is the balancing point. So ಇದನ್ನ ನಾನು P ಅಂತ ತಗೊಳ್ಳೋಣ. This is Q. So what is the balancing point? Initially the balancing point is 20 centimeter. ಇದು 20 centimeter ಇದೆ ಅಂದ್ರೆ remaining ಎಷ್ಟಿರುತ್ತೆ? 80 centimeter ಇರುತ್ತೆ. Okay, so if you apply the balancing condition, see the galvanometer is showing 0 deflection now. So what is the relation? P by Q is equal to balancing length divided by remaining length, that is 20 by 80. 20 by 80 ಏನಾಗುತ್ತೆ? 1 by 4 ಆಗುತ್ತೆ, right? So ಅಂದ್ರೆ P by Q balancing length less than 50 centimeter ಇದೆ ಅಂದ್ರೆ ಏನರ್ಥ? ಈ P Q ಗಿಂತ ಕಡಿಮೆ ಇದೆ ಅಂತ ಅರ್ಥ. Okay, smaller of the two, smaller resistance. What is the value of smaller resistance? That means what is the value of P is the question. Okay, so P value smaller is there because you see P by Q is equal to 1 by 4. Q is 4 times that of P, right? So we have the relation for P and Q, that is like this: P by Q is equal to 1 by 4. Now let's take the changed case. Next case ಅಲ್ಲಿ ನಮ್ಗೆ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ, a resistance of 15 ohm is connected in series with the smaller of the two. The null point shifts to 40. ಅಂದ್ರೆ ಇವಾಗ ಏನ್ P ಇದೆಯಲ್ಲ, across P we are connecting one more resistance of 15 ohm. 15 ohm plus P is our left gap. So right gap ಅಲ್ಲಿ ಏನಿದೆ, same value of Q is continuing, and now balancing point is shifting to 40 centimeter. So this is our balancing point. So balancing point 40 centimeter, the remaining distance ಏನಿರುತ್ತೆ ಇಲ್ಲಿ, this will become 60 centimeter. Okay, now if you write the condition P plus 15, ಅಂದ್ರೆ ಇಲ್ಲಿ series combination connect ಮಾಡಿರೋದ್ರಿಂದ P plus 15 by Q, this is equal to, write the balancing length. What is the balancing length is 40 and remaining distance is 60. Simplify ಮಾಡಿದ್ರೆ ನಿಮಗೆ 2 by 3 ಬರುತ್ತೆ. Right, now here we have to find out P value, smaller value ಎಷ್ಟಿದೆ ಅಂತ ಬೇಕು ನಮಗೆ. So ಅದಕ್ಕೆ Q ನ ಎಲಿಮಿನೇಟ್ ಮಾಡೋಣ. So we can eliminate Q from this equation. Cross multiply ಮಾಡಿ, Q is equal to 4P ಆಗುತ್ತೆ. Cross multiply, Q is equal to 4 into P. So value of Q ನ ನಾವು 4P ಇಂದ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ ಇಲ್ಲಿ. So P plus 15 by Q is equal to ಏನು, 4P. 4P, this is equal to 2 by 3. Okay, ಇವಾಗ cross multiply ಮಾಡಿ, you can write 3 into P, 3P plus 15 into 3, 45. This is equal to 4P into 2 will be equal to 8P. Okay, 3P plus 45 is equal to 8P. Take this 3P other side of the equation. We have 45 is equal to 8P minus 3P, 5P ಆಗುತ್ತೆ. Okay, so 5 ಮತ್ತೆ 45 ನ cancel ಮಾಡಬಹುದು. You get P is equal to 9. So the smaller value of resistance is equal to 9 ohm. So right answer is option 3. Option 3 will become the right answer. Okay, please look at the solution. Observe the solution. So here we are using balancing condition in two different situations. P, Q, 20 and for 80 centimeter first case. Second case ಅಲ್ಲಿ 15 centimeter resistance ನ series ಅಲ್ಲಿ connect ಮಾಡಿರೋದ್ರಿಂದ P plus 15 by Q is equal to remaining balancing condition 40 by 60. So unknown value, smaller resistance is coming out to be 90. If the question is what is the value of Q, Q value ಏನಂತ ಕೇಳಿಲ್ಲ question ನಲ್ಲಿ. ಕೇಳಿದ್ರೆ how to calculate the value of Q? Q can be calculated by this equation. Q is equal to 4 times P is 9, so it is 36. So value of Q comes out to be 36 ohm. Okay, so that's about questions related to meter bridge. Okay, which is the last concept of the chapter. Hope all these things are helpful to you. So ಮನೇಲಿ ಕೂಡ ಇದೇ ತರ ಕ್ವೆಶ್ಚನ್ ನ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ ಡೈಲಿ ಕಂಟಿನ್ಯೂಸ್ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರೆ sufficient time is there. So previous year questions ಮೇಲೆ ಫೋಕಸ್ ಮಾಡಿ, what type of questions are asked in previous year. So ಅದನ್ನ ನೀವು diligent ಆಗಿ ಎಲ್ಲ ಕ್ವೆಶ್ಚನ್ ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ you will be prepared for the final exam. Thank you so much. Thank you one and all.